Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we are going to have a discussion on locating a point in the coordinate system. And this basically is going to, of course, entail the coordinate system that we had earlier discussed on the rectangular coordinate system or the Cartesian coordinate system. In this specific system, we said that it has got what we refer to as three coordinates, or rather three coordinate axes. And this we are given it using x, y, and z given as such. So in any case, if we try to describe a point in this coordinate system, then therefore we're going to use those three axes to try and describe that specific point. So if I give an example for this, you have the x, y, and z axis represented in this coordinate system given as such. So if you have a point at this specific location that we're going to refer to point P, then therefore we're going to describe P in terms of the extension of this specific point for x, y, and z from a central point which we have referred to as the origin. Therefore, in trying to achieve this, we're going to look at to what extent this specific point has stretched from the origin along the x-axis. Perhaps if you try to look at this from this specific perspective, then therefore we're going to look at the stretch along the x-axis, which properly is going to be the distance between the origin of this specific point. And therefore we're going to look also at the stretch along the y-axis, which is perhaps a distance from here and to here, and the stretch along the z-axis, which of course is going to complement on the 2 points that I've mentioned for x and y respectively. So in this particular case, then therefore from the central point that we refer to as the origin, the points whereby this specific axes are going to coincide is going to be referred to as point B. So we can be able to describe point B, let's say, just change the direction of this, or rather the position of this. Let's say that point B is located at this specific point, so therefore we're going to have it coinciding with these two planes for the xy, and the yz, and the zx at this specific point. Therefore, we're going to describe that particular point B at that specific place. So if you try to illustrate this one in a 3-dimension, perhaps we can still give a straight for the y-axis at this specific point, the x-axis at this specific point, and the vertical distance from this specific point to here, giving the difference for the z-axis respectively. So that's how we're going to represent these specific changes in the three rectangular coordinate system, trying to describe what we refer to as a point. Earlier on, we had said that we have a right hand and a left hand system in the rectangular coordinate system, and sometimes this point can be located particularly on either the opposite direction of this axis. Now, in a 2-dimensional space, I've said that we can be able to give this one as x and y, and these respective opposite directions are going to represent the negative x and the negative y direction. And perhaps if we have another axis for the z that is being represented as such, we're going to have the negative z direction in this specific point. So for a 3-coordinate system, a point having the coordinates for x, y, and z can be represented using this specific procedure, and that one can either be positive or negative. Now, in some cases, we can be able to visualize this specific point in terms of planes. And I've mentioned that suppose we have a coordinate system that is having this, of course, illustration for the rectangular coordinate system x, y, and z that I've mentioned. We can be able to describe a point along the y-axis by trying to look at it as a point that is lying on this specific plane, whereby we're going to see that the extension or the distance between this specific point of origin to this point on the plane, then therefore is going to represent a stretch in the z-axis. So respectively, with that, we can be able to represent another point on the x-axis, perhaps at this specific point, and that is a stretch along the x-axis. And therefore, we can have another plane that is going to represent the stretch along that x-axis at this specific point. And similarly, we can be able to represent another point on the y-axis, which is going to have a plane on the y-axis indicated as such. So if we try to look at this in a 3-dimensional perspective, then therefore it's going to give us an insight as the description of a point basically as an intersection of what we call as an x, y, and z or rather this this xy, the yz, and the zx planes respectively. Therefore, this is another way in which we can be able to represent a point in the Cartesian coordinate system. And we're going to look at various ways as well, which are going to assist us to represent points in other coordinate system for the spherical and cylindrical system that we had mentioned earlier. And this is going to assist us, of course, in trying to analyze the locations and motions of various particles along this axis that we have mentioned for x1 and z. And this is going to be highly applicable, especially when we're going to learn the concept of motion and description of motions respectively. I hope then this is going to assist us in trying to describe the concept of a point in a three-dimensional, or rather in a rectangular or a Cartesian coordinate system. And this is going to be fundamental for us, especially when we are going to consider the ways in which we can be able to describe these specific points in terms of numbers, or try to analyze the change in position. So in this case, if perhaps a particle is located at this point and it's moved to another point, which is P prime, then therefore we're going to consider the case for the change in the x-axis, the change in the y-axis, and the change in the z-axis, which are going to describe the change in position of this specific particle. And that is going to be very handy in trying to describe the concept of a vector analysis, especially when we're trying to consider change in positions and other applications like reflection, the rotation, etc. So catch us in our next videos. We're going to look at various ways in which we can be able to represent either surface or volume in space. And now considering these other vector, or rather these other types of coordinate system that we have mentioned for the cylindrical and the spherical coordinate systems respectively, and their various elements. So that is it for now, guys. Bye. Catch us in our next video. God bless.